All right, let's talk networking. We're always looking for that smarter, faster path for our data, right? Well, today we're going to break down a really brilliant piece of engineering that does exactly that. We're talking about DMVPN Phase 3. Let's dive in and see how this thing creates the ultimate shortcut for network traffic.
So here's what we've got on tap. First, we got to understand the problem, right? The suboptimal detour our data sometimes gets stuck on. Then we'll jump into Phase 3's clever fix. We'll look at the protocol that's the brains of the operation, how it cleverly overrides normal routing, and then the big payoff, why all this directness actually matters.
Okay, so let's set the stage. The main problem we're trying to solve here, it's all about that hub and spoke model. Picture this. You've got tons of remote offices, we call them spokes, and they all need to talk to each other. Now, the old school way forces every single one of those conversations to go through a central hub first. And yeah, that gives you a lot of control, but it's definitely not always the fastest way to get from point A to point B. And this is a big step up from the previous version, Phase 2. See, with Phase 2, the first packet had to make that long trip to the hub, and then the hub would trigger a direct tunnel. It worked, sure, but it was reactive. It waited for the problem to happen. Phase 3, it's proactive. The hub sees that very first packet and immediately tells the sending spoke, hey, there's a better way to do this. It redirects traffic before the conversation even really gets going. Which brings us right to Phase 3's clever shortcut. And the genius here is that it's not about building a million connections ahead of time just in case. No way. It's about having an intelligent, on-demand system that spins up the most efficient path only when it's needed. It really is like a smart GPS for your network, finding the best routes on the fly.
Okay, so the real hero of this whole story is a protocol called NHRP, the Next Hop Resolution Protocol. Think of it like a directory service, or maybe the network's address book. It's the thing that lets one spoke router ask the main hub, hey, I need to talk to spoke B, what's their direct number? The hub has all that info and provides the answer. That's what makes the whole shortcut thing possible.
So you're probably wondering, how does this magic actually work under the hood? Well, let's walk through the step-by-step conversation between the spokes and the hub. It's a really neat, structured process that makes it all happen.
All right, so first things first, everything kicks off just like you'd think it would. Spoke A needs to send something to spoke B. It checks its routing table, which says, hey, the next hop is the hub. So that first packet makes the trek, all the way from spoke A up to the hub. The hub then does its job and forwards it down to spoke B. Yeah, it's inefficient, but this is the critical first step that gets the whole optimization ball rolling.
Okay, now this is where the smarts kick in. The hub sees this traffic taking the long way around, and it doesn't just sit there, it takes action. It shoots an NHRP redirect message back to spoke A. It's basically saying, hey, you don't need to do this through me. Spoke A gets that message and goes, oh, okay, and immediately sends an NHRP resolution request back to the hub, asking, got it, so what's spoke B's direct address? The hub replies with the IP, and bam, this is the magic moment, spoke A installs a brand new shortcut route in its forwarding table, pointing right to spoke B.
And the result of that super quick back and forth? It's awesome. From that point forward, all the rest of the traffic in that conversation zips directly from spoke A to spoke B. The hub is totally out of the picture. A dynamic, on-demand tunnel has just been built, and the path is now as efficient as it can possibly be. So you might be thinking, wait a minute, does this mean we're constantly messing with our main routing tables? That sounds complicated. And the answer is, surprisingly, no. This is where the design is just so elegant. Phase 3 makes a really clever distinction between your stable underlying routing and the actual dynamic forwarding of your data. This really sums it up perfectly. Your main routing table, the one built by protocols like EIGRP or OSPF, it still says, for everything, go to the hub. That's your general roadmap. It doesn't change. But then NHRP comes along and provides a specific on-the-fly instruction, like a traffic cop waving you down a side street. It says, yeah, I know what the map says, but for this specific destination, take this shortcut instead. And this is so important because you really do get the best of both worlds here. Your overall routing design stays simple and stable. The hub is still your central point for control and for finding things, but the actual data flow is super efficient and totally distributed. It's this separation of jobs that makes the whole system so powerful, so scalable, and so robust. Okay, so we've spent a lot of time on the how. Now let's get to the really good part, the why. Why do we go through all this trouble? What's the real-world payoff for all this directness? Let's break down the benefits.
And wow, This chart really tells the story, doesn't it? Just look at that difference in latency. Taking the long way through the hub could add a ton of delay. We're talking going from a snappy 20 milliseconds to a sluggish 80 milliseconds. By creating that direct path, you're massively boosting performance for anything that's sensitive to delay, like voice calls, video conferencing, you name it. This isn't just a minor improvement, it's an absolute game changer for the people actually using the network.
So when you add it all up, the advantages are just undeniable. First, you get full optimization. The hub is no longer a bottleneck for spoke-to-spoke traffic. Second, your network becomes incredibly scalable. You can support thousands of sites without crushing your central infrastructure. And maybe best of all, the configuration is way simpler because you don't have to manage this tangled web of complex routing policies on all your spokes. And you see this in the real world all the time. Think about huge companies with hundreds or even thousands of branch offices. This is perfect for them. It lets all those offices talk to each other efficiently without bogging down the main headquarters network. It's also a huge deal for service providers. It lets them offer their customers these really dynamic, high-performance VPN solutions that can scale like crazy. So when you boil it all down, DMVPN Phase 3 is just a fantastic example of smart, dynamic network design. It gives you the simple control of a hub-and-spoke network, but with the high performance of a fully distributed mesh. It takes a really complex problem and solves it with a beautifully elegant shortcut. And that leaves me with one final question for you. As our networks keep getting more and more distributed, what do you think the next great shortcut in routing technology is going to be? Something to think about. Thanks so much for joining me.